So this is where we need to come back to the question of our condition monitoring technologies, because, you know, on the one hand, we might have an electrical hotspot, which doesn't create any infrared, doesn't create any ultrasound, doesn't create any vibration, doesn't create wear particles. You know, we might be limited to just one technology to detect this problem. We have to understand, well, at the point where we detect this, how long is it until I will need to act? On the other hand, you know, with a gearbox, I can use vibration analysis, ultrasound, oil analysis, and ferrography, you know, wear particle analysis. And the beauty of using multiple technologies, if we perform the tests properly, if everyone is skilled, then we can combine what we know. We can look at the oil analysis results and make sure the viscosity is right and there's not water contamination and things like this. I can look at the ferrography and I can see, well, are there wear particles, and are the wear particles coming from the bearings or the gears or you know, any other metallic parts. I can look at the vibration patterns. I can look at the ultrasound. You know, and I could use infrared. You know, it might be that there's a problem with the gear slipping on its shaft or something like that, and it's generating heat, or, you know, but certainly, you know, understanding the failure modes of this gearbox and the bearings and so on inside, if I understand the failure modes, then I can use the appropriate technologies. But the other point of my discussion here is to say that it's important that, you know, the left hand understands what the right hand's doing and a little about their technology. It'd be great if the vibration analyst knew to ask about the oil sample and, you know, making sure that the wear particle analysis is being performed. Otherwise, the vibration analyst might just say, oh, well, you know, I've taken my tests and, you know, I'm not quite sure what the fault is, or I'm seeing a little bit of a problem. And it may be some time until the next oil sample and the next, you know, analysis is performed. Now, by that stage, the problem might be much worse. And if this is a critical gearbox, or it's a gearbox that has a long lead time, well, then that's a problem. The bottom line is, the more that the reliability engineers understand about the technologies, the more that each condition monitoring specialist understands about each of the technologies, the more likely it is that we will be able to make a truly informed decision. You know, and the bearings, obviously, we can use a combination of technologies, understanding that some will give us an earlier warning than others. Some will give us much more information about the nature and severity of the fault, rather than just indicating that there is a fault. You know, that whole picture puts us in the driver's seat. You know, we're in a position to really know what's going on with confidence. And the more critical the equipment is, the more important it is that we have that confidence that we can do that job properly. So again, I come back to this question of how the condition monitoring team is working, because certainly there are some organizations where the vibration analysts sit here, the reliability engineers are somewhere else. The infrared might be run by the electrical department, and the ultrasound people. You know, everyone's working separately is the point I'm trying to make. And the different people don't understand each other's technologies, and it's just a wasted opportunity. It's just a wasted opportunity. What we really need is just one clear picture of the health of the equipment, using all the information we have available, all the expertise, so that we can make the best decision as early as possible.